Okay, so we're on to the next major tissue type, connective tissue. We'll spend a lot of time on connective tissue and not near as much time on the two remaining after connective tissue, muscle and nervous. So don't panic too much. The functions of connective tissue, you can see that there are a lot of functions, and no single tissue has all of these functions. Most of them only have a couple, like two perhaps. So examples of physical protection, fat is padding. It provides some protection. So fat then is an example of a connective tissue. Other physical protection could be like bones. Support and structure, definitely bones, also things like cartilage. And there are sometimes layers of connective tissue surrounding some organs that help give it a little bit of support and structure. Binding of structures, as the name implies, connective tissue. Interestingly, it's called connective tissue, but only one of the many functions is binding. But this could be something like ligaments or tendons. Storage. There's a lot of examples of storage. Well, fat, we can go back to that. That has energy storage. In addition, you might have calcium storage in the case of bone, for instance. Transport. There's only really one connective tissue that does transport, and that's blood, transporting stuff all over your body. And then immune protection. So this is certainly the case with blood. Blood has immune cells in it, but it's also true of other connective tissues. Like we'll talk about layers of connective tissue inside of your skin. Most immune cells actually don't just stay in the blood. Immune cells will leave the blood and they'll go to the site of infection. So if you look at a lot of connective tissues, you'll find wandering immune cells that have left the bloodstream and are moving towards that site of infection. And so connective tissue provides like a passageway, a pathway, some way for the immune cells to get a way for the immune cells to get to where they're needed. So connective tissue components. Connective tissue does have cells in it, a lot of cells, and there's different cell types we'll talk about in a bit. But it also has what we call extracellular matrix. Sorry, I don't know why that popped up. That extracellular matrix contains two major components. It contains protein fibers, which in a little bit I'm going to go in depth in the different types of protein fibers. So these are made by cells, but they're really just strings of protein. They're not cells themselves. So matrix has a lot of protein fibers, and it also has this stuff called ground substance. And ground, it's just kind of a strange word, and it's hard to imagine what this stuff is. This is how I always think of it. This is kind of crazy, but my mom used to make these Jell-O molds. They were horrible, and she would find a way to get like fruit suspended in it. That's what I always think of it as, is like a Jell-O mold, like this gel substance with stuff like protein and little cells floating in it. So the white space, what you can't see, is the ground substance, and all this other items, the cells and the protein fibers, are just floating or suspended in that ground. Most ground is in fact gel, kind of like that Jell-O mold, but sometimes it can be liquid, like in the case of blood, or solid in the case of bone. But the vast majority of them are kind of like this gel. It's made of, you don't need to know this, but it's made of these molecules called proteoglycans, are very common, but they end up with this kind of gel-like consistency. So this is a very important point, the existence of a matrix. Extracellular matrix is rare or almost non-existent in a lot of other tissue types. That is part of what defines connective tissue, is this matrix, because almost all the tissues except for one have a lot of it. So by definition, a connective tissue has lots of matrix, a lot of stuff outside of the cell. However, it's not the best defining feature of a connective tissue. Here are all the connective tissues. This is overwhelming. We're going to go through each one of these in turn, but all of them have lots of extracellular matrix except for one. It's actually adipose or fat. Sorry, I flipped up again. Adipose doesn't have a lot of matrix. It's just cells. So matrix alone is not the best definition of connective tissue, The best definition of connective tissue is a common origin called mesenchyme. So what on earth does that mean? So by origin, I mean a developmental origin. So we're talking about actually very early stages of development in the embryo. So when an embryo develops, at first it's just a bunch of undifferentiated cells. So it just means cells that are all pretty much similar to each other, but have the ability to become anything, any type of tissue. And then after a few weeks, and you do not need to know the timing of this at all, but after a little while, you get 3 different types of major types of tissues start to develop, and they then become, finally these other types of tissues that we talk about in this class. But one of those is called mesenchyme. It's an embryonic tissue, and it is pretty generalized. It does become everything from bone to blood to fat to all these other kinds you don't even know yet. So mesenchyme is an embryonic tissue, and it gives rise to all of these different tissue types, depending on where you find it in the body. That really determines which of these major types it's going to become. So mesenchyme is the thing that all connective tissues have in common. They have the same embryonic origin. We are going to learn all of these in chapter 4, except bone. We're not going to learn bone. We're going to save that for chapter 6. And we're not going to learn blood. We're going to save that for chapter, it's not for a while, I think it's 22. So those 2 are not going to be included, but you can see there's plenty more for us to do. And we're going to start with what we call connective tissue proper, of which there are, broadly speaking, 2 types. There are loose and there are dense types. Loose means very few fibers, a lot more ground substance. Dense means lots of fibers, very little ground substance. You can tell this visually. You should be able to see when there's lots of fibers versus not very many. And I'm going to give you an example of that. This tissue, and we'll get into specific tissue types in a minute, but I just want you to look generally at this image. You can see there are fibers. You can see some lines here. But you can also see lots of white space. White space equals ground. So whenever you see white space, it's not that it's empty. It contains that, usually it's a gel. I'll give you another example really quick to give you an idea of dense. That's dense. So there's lots of fibers. There's barely any white space. You can see a little bit here. Again, that white space is ground. There is ground substance in there, but there's not very much. So this would be a dense tissue.